Good evening, everyone. My name is Evelyn, and I'm a scientist. Me and a few of my fellow other scientists, Hingwei, Richard, Sarah, and Hao Chen, have decided to venture into the world of business to become entrepreneurs. So recently, we set up a startup known as Aircons Inc. We set up Aircons Inc. as we believe that global warming has indeed resulted in higher global temperatures, and because of that, more consumers are buying aircons to stay cool. Using the latest trademark sunflow technology, our aircon is unlike no other aircon currently in the market. Unlike conventional aircons that run on electricity, our aircons have a cost-saving function that allows you to save costs while saving the environment. This cost-saving function consists of a battery pack charged by solar panels that will be placed outside the owner's house. This battery pack has a maximum charge of 10,000 watts, and it requires a minimum charge of 8,000 watts to function for an entire 8 hours worth. So hence, moving on to our project statement, in conducting this project, we are trying to find out if temperature is indeed rising every year, hence showing us that there is global warming. Aside from that, we are also trying to find out if intensity of sunshine is increasing, hence providing us with a viable and potential source of energy for our project. I'll be now handing on the time to our other physicist, Richard, to elaborate further. Thank you.
So basically, I will bring you through our energy conversion formula for our sunflow technology, for our air conditions. Basically, the energy converted equals to the duration of sunshine hours multiplied by 0.3 to 270 log of the surface area of solar panels multiplied by the cube root of temperature. So this is basically the formula that our scientists have come up with to calculate the amount of energy converted from the amount of sunlight that we obtain. So next, basically the data source that we have collected our information from is from data.gov.sg, and the variables that we are taking and the data that we're taking is the mean sunshine hours as well as the average temperature. So our business question for today is whether the mean temperatures have risen in Singapore, i.e. whether global warming is true, and to analyze the feasibility of these aircons, whether they will be effective or efficient enough in Singapore's context, because we are applying this in Singapore. And the last business question would be analyzing the linear relationship between temperature as well as sunshine hours, because we want to see that whether in the future there is a sustainability, and whether in the future this sort of a concept will be applicable. So next. Yeah, so for our mean temperature data visualization, we use the Python programming, and we use Matplotlib to plot out a line graph showing the mean temperatures from the year January 1982. This is monthly temperatures, 1982 January all the way until September 2018. So we see a general rising trend for the mean temperature over the year. However, we would like to in order to make sure that this is that we are able to prove, or we have strong evidence that a global warming is present or that temperature is rising, we decided to do hypothesis testing. So now we're passing on my time now to Hao Chen, scientist Hao Chen, who will be talking to you more about our hypothesis testing. Thank you.
Thank you, Richard. I'm Hao Chen. And at this part, our group wants to find, with the help of hypothesis testing, our group wants to find if temperature have increased since the 1980s. So for this case, our sample frame will be from 1982 January to 1989 December. What we'll be trying to do is to have 50 samples with our sample size of 50, but 10,000 different iterations. What we have plotted here is the sample means of these 10,000 iterations, and it resembles a normal distribution. So as you can see here, we're trying to use CLT to approximate the sample mean to the population mean. Next, please. So for now, we'll be using confidence interval to determine whether or not our current temperature is above the boundary. As you can see here, the 95 percentile, since it's a one-tailed test, we're using the 5% significance level. The 95 percentile temperature will be 27.3 degrees Celsius. So in order to reject null hypothesis, our current temperature must be above this threshold. And our monthly mean temperature of September 2018 is 28 degrees Celsius, which is significantly higher. So our group concluded that there is significant evidence to reject null hypothesis. Next. However, our system seems to have failed to take into consideration of inter-month temperature variation within the years. Therefore, we use another graph to visualize the temperature differences. So in this case, the green color represents a cool temperature, yellow color means warm, and red color means hot. How we obtain this is by simply taking the difference of the minimum temperature and the maximum temperature and split it into 3 equal intervals. The coldest will be cool, the second coldest will be warm, and hottest being hot. So what we'll plot here will be 2 numerical variables versus 1 categorical variables. As you can see here, we've observed certain similarities within the month, November, December, January, February, and some similarities between March, April, May, and June, and similarities between July, August, September, and October. So what we'll be doing next will be separating the year into 3 different time groups. And we'll be repeating the hypothesis testing to see whether or not the entire 9 months that we have the data on 2018 falls above exceeds the confidence interval. However, it is important to take into account that due to the fact that we are splitting the entire sample into 3 different samples, our sample frame decreased significantly. So in order to ensure that the sample frame is large enough to do our simple random sampling, we will be increasing the sample frame from 1982 to all the way to 1999. So the null hypothesis will be changed to an increase of the 1980s and 1990s instead of just 1980s. And so from here, running the Python code, the group 1, group 2, and group 3, we have obtained 3 different confidence intervals and 3 different distributions and 3 different upper bounds. And under the Python code, we have rejected all null hypotheses other than that of the month of Jan. Therefore, we are pretty confident to conclude that there is significant evidence to believe that global warming is true. Next, I'll be handing over my time to Steve to test the sunshine hours.
So moving on, I'll be running through the analysis of sunshine hours to find out the feasibility of the workings of our aircon. So firstly, we use matplotlib in Python to plot the mean sunshine hours against the year from 1980s to 2018. And we found out that similar to mean temperature, the mean sunshine hours have been increasing as well. And going further, we made use of the energy conversion formula to obtain the energy generated given the monthly temperature and sunshine hours. And then we went on to plot the histogram of 10,000 iterations based on 50 sample means and calculated the probability of energy converted being more than 8,000 watts, which is the minimum required energy in order to function the aircon. And we concluded that the aircon will work 97.5% of the time. So now I'll be passing my time on to Sarah, which will go through the linear regression model of our aircon.
Thank you, Steve. Now I'll be sharing with everyone the linear regression model that we conducted. The model was done to establish a linear relationship y equals beta 0 plus beta 1 times x between mean sunshine, represented by y, and mean temperature, represented by x. As seen in our OLS regression results, we can tell that the coefficient of mean temperature, beta 1, is equals to 0.72. This means that mean sunshine hour increases by 0.72 hours whenever we have a 1 degree Celsius increase in mean temperature. Apart from that, our p-value is 0.000, which is less than 0.05. This means that it is statistically significant. However, it is noteworthy that our AIC and BIC have large values. In fact, they are 1287 and 1295 respectively. On top of that, the adjusted R-squared value, 0.235, is relatively low too. This means that our model might be plagued with errors. To wrap things up, our air conditioners can work 97.3% of the times. Also, as temperature rises, our sunshine hours will increase too. This means that it is not a one-time event and this is a feasible project, so we can continue with the manufacturing procedure of our air conditioners. Thank you very much.